Alright, here's a fun thing you can do with polygons. So start with any polygon you like. The smaller the easier, but the less interesting. I have gone for an octagon here just because I have. What you need to do first is something that's called triangulate. We will have done this before with angles, but you just join vertices up without crossing, and there's no right or wrong way, and whichever pattern you choose will give you a different result. So you're free to choose whichever pattern you see fit to join them up. So you must make sure that all the shapes in here are triangles. There aren't any quadrilaterals left. And then you go round the vertices, which are the corners, and count how many triangles they're attached to. So this vertex here is 2 triangles next to it. This vertex here has 1, 2, 3, 4. This is only 1 triangle. This is 2. This is 3. This is 1. This is 4, and this is 1. So we now have a sequence of numbers 2, 4, 1, 2, 3, 1, 4, 1, and it repeats 2, 4, 1, blah 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 blah. Okay, and that list of numbers is something we can use to build what is essentially a pretty pattern. There's some maths behind it if you want to research, but we can just start with this. So I've got a row of ones. I've done it at this angle so we can do something that's coming later. So we're going to get these numbers that we just worked out and feed them in here. 2, 4, 1, 2, 3, 1, 4, 1. So if we transfer those values across to this pattern, there's a row of ones across the top, and then we've got the 2, 4, 1, 2, 3, 1, 4, 1, which we can repeat over and over, and indeed we should to make this complete. So 2, 4, 1, 2, 3, 1, 4, 1, 2, 4, 1, 2. And there's a generating rule to get the next row. 2 4s are 8, and we'd like 1 times something to be 1 less than 8. So we're aiming for 7 here, so 1 times what is 7? Well, that's got to be a 7. So this top row is fairly straightforward. 4 1s are 4, take away 1 is 3, 3 times 1 gets us 3. So because we're multiplying by 1, it's just 1 less than the product of these. It gets a bit more interesting further down, so I'll do this row quickly.
7, 3, 1, 5, 2, 3, 3, 1. And those 8 values will repeat because these 8 values repeat.
So this is the first sort of tricky, interesting one. 7 3s are 21. 7 3s are 21. 1 less than 21 is 20. 4 times what is 20? Well, it's 4 times 5. Which means that should be a 5. We've got an easy one there. 5 times 1 is 5. Take away 1 is 4. So 2 times what is 4? Well, it's 2 times 2. So you've got these right if you multiply those, and it's 1 less when you multiply those, which you can write as this formula: west east subtract north est should be north south rather should be 1. If you have a smaller polygon to start with, you have fewer calculations to do. So I'm now going to rattle through these as quick as I can to get this done. And it looks like we've got some 1s here. And in fact we get 1s all the way across. So that is the end of the calculations. If you want, you can just repeat yourself to put the same row of numbers across the top and do it again. But that will do for now. If you take your numbers from the polygon in this way, you will always eventually get a row of 1s closing it off, unless you make a calculation error like I did over here. You might be interested to work out how many rows you get every time. There's a pattern to be spotted there. And the reason that this may or may not be worth doing is to show you some interesting patterns. So I'm going to whip out the colours now, probably fast forward a bit, and do all the ones in a colour, all the twos in a colour, and so on. So and you get that frieze pattern. If nothing else, we've learnt why I'm not an art teacher. So hopefully you'll be able to create your own. Start with any polygon, triangulate, get the numbers, see what pattern you get. I hope to see some better patterns than this, some neater drawn patterns at least. Have fun.